Hello everyone, welcome to the channel. And today, let us perform a mathematical operations in Google Earth Engine using code editor. Let's get started. Let us perform a mathematical operation using code editor like different band combinations or image combinations. Here we have defined as how to get a feature collection with the boundary. So suppose if you want to refer the particular country database, suppose you want to refer a database. So here we are defined as where countries is equal to doubly dot feature collection. So US United States of Department of State large scale country boundary polygon 2017. So for that database we are specifically referring a country called Egypt. So we have defined by a variable Egypt equal to country dot filtering dot filter. So referring to that particular country called Egypt. Now let me show you that the USDOS refers to the United States Department of State, and the LSIB refers to large scale international boundary polygon. So we are referring to the database. From that we are filtering the particular country called Egypt. So in this video we require two different Landsat 8 image. So here 2014 Landsat and 2017 Landsat image. So how to load a 2014 and 2017 Landsat 8 image into Google Earth Engine. So in this we're going to load a Landsat 2014 image into Google Earth Engine. For that, let me explain to you. So here the variable we defined. So here we defined a variable called an image 2014 that is referring to a Landsat image, Landsat 8 image of 2014. So doubly dot image collection, referring to the image collection. So this is the code we can able to access the Landsat 8 image. That is referring Landsat, and LC is the Landsat 8 image collection 1, and filtering with date from 2014 January to 2014 December. So here we are filtered by dot filtered bound by Egypt. We are filtering by the country called Egypt, and here the median function we are using. So suppose we have the satellite images are ranging from January to December. To get one particular satellite out of it, so we are using a function called median. So median here, and we want to clip by Egypt. So I want to get a satellite image that is clipped by the country Egypt boundary. So next we defined it as the variable. Similarly, we are defined a variable called image 2017 Landsat 8 image. So let me remove this one. So now let me show you that. So here we defined a variable called image 2014, and is equal to, we are referring to an image collection of Landsat 8 series collection 1. So we are filtering it by the date called from 2017 January to 2017 December. So we are filtered bound by Egypt. So we are filtering by Egypt, only the Egypt. And with the median, we have defined a function called median. So here the median that refers, so the satellite images ranging from January to December. So to get one particular satellite image from this series of this timeline, they're using the function called median. So here the clip function we are used to clip the satellite image by Egypt, by the country Egypt. So now let us perform further. So we have let me show you how to compute an NDVI. So what is an NDVI? So NDVI is a normalized difference vegetation index. Now let me show you that. So NDVI defined as a normalized difference vegetation index. So a normalized difference vegetation index quantifies the vegetation by measuring the difference between the near infrared, which is the vegetation strongly, which reflects the vegetation strongly, and the red light. So to calculate the NDVI, that is Normalized Difference Vegetation Index, we are using this formula called NIR, that is near infrared minus red band, divided by NIR, the near infrared plus the red band. So suppose, for example, if you get a result as a negative values, it is highly likely to be a water. On the other hand, if you have an NDVI value close to +1, then it's definitely an indication of a dense leaves or dense vegetation. But if an NDVI is close to 0, there is no likelihood of green vegetation or green leaves. It could be an urbanized area. So here in Google Earth Engine, we have performed NDVI analysis. So let's get started. So let me explain this. So here we have defined a variable called NDVI 2014. So we defined a variable called NDVI 2014 is equal to image 2014. So we are referring this 2000 for image 2014 image. So we are importing that image. So this is the image 2014 and applying an algorithm called normalized difference. So that is refers to the that NDVI, the normalized difference vegetation index. Now let me show you that formula. So this is the formula NDVI, NIR, that is near infrared minus red band, divided by NIR plus red. So this algorithm functions applies this particular formula and using the band 4 and band 3. So here the band 4 that is refers as NIR, that is near infrared band, and band 3 that refers a red band. So it performs that algorithm as shown you earlier, this formula. And similarly, we are defining another variable called NDVI 2017, referring to image 2017. That is, we are importing that image, that is here, the image 2017 Landsat 8 image. We are importing into the here and applying the algorithm called normalized difference vegetation index using the band 4 and band 3. The band 4 refers to the NIR and band 3 refers to the red band. So here we have two different NDVI values, that is 2014 and 2017 NDVI values. So the next operation we're going to perform is to find the difference in the NDVI we have imported. So let us find a difference between an NDVI difference between 2014 and 2017 of Landsat 8 image. So to perform a multi-band difference image for NDVI 2014 and NDVI 2017. So suppose if you want to define to find the difference, we are using a variable called difference, where a variable called difference equal to NDVI 2014. So NDVI 2014 will be our baseline. So subtracting in the dot subtract NDVI 2017. So to find the difference, we are doing is to NDVI 2014 minus of NDVI 2017. So the result will be, so if it is a positive value, the positive value here indicates the decline in vegetation, and suppose it has a negative value, so it indicates uh, increase in the vegetation or increase in the afforestation. So the next is we defined a variable called NDVI palette. We are referring to color ramps. So these are the color ramps we're going to define for our imported image. So let me show you that the color ramps. So here the number here, this number indicates a color ramp of this color, and this number indicates the color ramp of this particular color. So let me show you. I will choose another color. So this series of color has a color palette of this color. So this color number has this code has a this particular color called orange. So likewise, I have selected three sets of color for my image. So next is I defined a variable var NDVI palette. These are the color scheme. And next is we're going to add a layer. Now let me remove this. So here we have shown you that map add we're going to add a layer, the NDVI 2014. That is refers to this one, NDVI 2014. And similarly, we're defining the minimum value of minus 3.0 to a maximum value of positive 0.4. With the color palette, we have indicated this one, so referring to NDVI palette. So this one have this color ramps for NDVI 2014. And similarly, we have added another layer called NDVI 2017, referring to this one, NDVI 2017 image, that is a Landsat 8 image, with a minimum value of minus 0.3 to a maximum value of positive 0.4, with the color palette of NDVI palette, that is referred here, this one, NDVI palette. NDVI, so this is NDVI 2017 for Landsat 8 image. So to find the difference in that NDVI, so we performed using this algorithm. So using this variable, so we are adding that layer also. So using map dot add layer. So adding this layer, so variable difference. So difference indicates this variable difference with a minimum of minus 0.3, maximum value of 0. Positive 0.4, and color palette is similar one. So we're going to display is the difference in the NDVI. So last we have defined as map dot center object. So this refers to on centering the this particular country with the zoom scale of 6. So now let us run this code and let us see the result. So now let me run this code. Go to the option called run. So you can see that. So now we have in4. Let me show you the layers. We have NDVI for 2014 and NDVI for 2017, and the difference in the NDVI of 2014 and 17. So now let me show you 2014. So this is the NDVI 2014. Now let me show you the NDVI 2017. So you can see a slight variation, slight changes in the vegetation. So I have shown you NDVI 2014 and 2017. So there is a slight change in the vegetation. You can see there is a very slight difference. So now let me show you the difference. NDVI difference in NDVI of 2014 and 2017. So here, now let me zoom. So now let me check the vegetation changes from 14 to 17 using an option called here inspector. So now we can inspect this. I've clicked here. Let me drag this. So we can see that the NDVI 2014 was minus 0.021 and NDVI 2017 indicates 0.023. NDVI difference here indicates a minus value of 0.045. So which indicates the negative value indicates that vegetation has been increased periodically from 2014 to 17. So we have performed the difference by NDVI 2014 minus NDVI 2017, which indicates that when a negative value indicates there is a increase in the vegetation from 2014 to 17. So similarly, if you are seeing a positive value. So similarly, a positive value indicates a decline in vegetation from 2014 to 2017. Now let me show you that. So here you can see that the difference in NDVI indicates an NDVI value of 0.000, which indicates the positive value, which indicates the a decline in vegetation from 2014 to 2017. So in this video, I have shown you that how to perform a mathematical operation in Google Earth Engine, and we have loaded an image of Landsat 8 image of 2014 and 17 into Google Earth Engine, and we have computed the NDVI, and we have computed the difference in the NDVI, and at last we have shown you the NDVI color palettes. So thanks for watching. Please subscribe to our channel.